Exercise 5.7. First 10 questions are about second derivatives. Right. So question number 1 here. You are given x squared plus 3x plus 2. Let this be, for example, y equals to x squared plus 3x plus 2. So therefore dy by dx, you know it's very simple, which is 2x 3x3 2 0, and again if you do it again, d square y by dx square, 2 being constant as it is, derivative of x is 1 3 0, so answer is 2. Okay, question number 2, second question. Here let's take y equals to x raised to 20. So therefore y1 equals to, you can call y1 or dy by dx, both are same, you know. y1 equals to 20 into x raised to 19, 1 less, you know, n into x raised to n minus 1. If you do y2, therefore 20 being constant as it is, same formula, 19 into 1 less, which is 18. So this is 380 into x raised to 18. Therefore y2 is this. Okay. Question number 3, third question. You can try. Fourth also you can try. These are 2 elementary questions. I'll go to question number 5. There you have, let's take y equals to x cube into log x. X cube into log x. So therefore, what is y1? Product rule. X cube as it is, derivative of log x, 1 upon x, plus log x as it is. What's the derivative of x cube? 3x squared. So here, therefore, y1 equals to, this is x squared plus 3x squared into log x. If you want, you can take x square common here. So if I take x square common, or you can continue as it is. Let me continue with this only, doesn't make any difference. So y2 will be here, y1 is this. So therefore y2 will be derivative of x squared 2x. Here you need to use product rule, remember. 3 as it is. Now here product rule, x squared as it is, derivative of log x 1 upon x, plus log x as it is. What's the derivative of x squared? 2x. Product rule, I repeat, x squared as it is, derivative of log x 1 upon x, log x as it is, derivative of x squared 2x. So finally 2x plus, this is just x, if I take inside 3x, and this is 6x into log x. So finally 5x plus 6x into log x. This is y2, second order derivative, remember. Next question. Let me go to question number 8 now. Let's take fx equals to 10 inverse x. So what is f dash x here? You know 1 upon 1 plus x squared, you know this. Now derivative of this, so f double dash x. How will do this? You know, imagine this as x. You imagine this as x. So this looks like 1 upon x. What's the derivative of 1 upon x? Minus 1 upon x squared. By chain rule, d by dx of 1 plus x squared, right? You have used chain rule effectively, remember. What I did here, consider this as x. What's the derivative of 1 upon x? Minus 1 upon x squared, and then turn in derivative of this. Okay, so here 0, here 2x. So minus 2x upon 1 plus x squared, the whole square. This is f double dash x. Okay. question number 10 also I'll try for you. Let's take fx equals to sine of log x. So what is f dash x here? F dash x equals to chain rule. Imagine these are x, derivative of sine is cos, so cos of log x into, by chain rule, derivative of log x, which is 1 upon x. I have dropped one step. Imagine these are x, derivative of sine is cos, log x as it is, and then into derivative of log x, which is 1 upon x. Now therefore f double dash x. So how will do this? Product rule again. This is like one function here. This is the other function. Product rule, remember. So I'll keep this one as it is, cos of log x as it is, into derivative of 1 by x, you know, minus 1 upon x squared, plus now 1 upon x as it is, into differentiation of this. So again chain rule. Imagine this as x, so minus sine of log x, derivative of cos, which is minus sine of log x, into differentiation of log x, which is 1 upon x, by chain rule, as you did here, remember. This is differentiation. Just you simplify and match with the backside answer. Every time when you do at home, you always compare your answers with the backside answers, remember. Question number 12. You are given y equals to cos inverse x, and you are asked find d square by dx square in terms of y alone. Okay, so we in the solution will start with this here, y equals to cos inverse x, therefore dy by dx equals to, you know, derivative minus 1 upon root of 1 minus you know, x squared. This much we know. Now here in the question you are asked that your answer should be purely in terms of y, remember. So what I'll do, I'll put the value of x before I do the second derivative. So what is x? You know, cos y from the given data. This much we can see from the given data. Okay, here. So therefore dy by dx equals to minus 1 upon, if I put the value here, 1 minus cos squared, which is sine y, that square root and square will get cancelled. So finally you will get the cosec y. This is dy by dx. Now again we differentiate it. So here d square y by dx square. That means you are differentiating with respect to x, remember. So you need to use the chain rule here. Minus, what's the derivative of cosec? You know, minus cosec y into cot y into, by chain rule, derivative of y with respect to x, that's dy by dx. Remember, on the right hand side you have used y as x. When you write d square y by dx square from dy by dx, that means you are differentiating with respect to x. So you need to imagine y as x here. So into derivative of y with respect to x. So this gives us plus cos y, cosec y into cot y into value of now dy by dx. What is that? It is minus cosec y. So your final answer is minus cosec square y into cot y. This is required d square by dx square. The next question is here, y equals to 3 times cos log x plus 4 times sine of log x. We want double derivatives. So we differentiate it with respect to x here. So dy by dx equals to, here chain rule, imagine this as x, derivative of cos is minus sine of log x into by chain rule derivative of cos x 1 by x plus 4 times this one as it is. Imagine this is x. What's the derivative of sine cos of log x into derivative of log x by chain rule 1 upon x. Now normally in double derivative questions, before we do the second derivative, let us simplify this. So I'll take this x on the left hand side. So x into dy by dx equals to minus 3 sine of log x plus 4 times cosine log x. Now again we differentiate it. Again differentiating with respect to x. So on the left hand side we have product rule. Remember, x as it is. What's the derivative of dy by dx with respect to x? D square y by dx square. Plus, now dy by dx as it is. What's the derivative of x? It is 1. Equals to, again here chain rule, minus 3 as it is. Imagine this as x. So cos of log x by chain rule derivative of log x 1 upon x. Plus, here plus this 4 as it is. Differentiation of cos is minus, here sine of log x as it is into derivative of log x by chain rule 1 upon x, as we did in the previous step. Again you take x over here, this x will come this side, so this is x square, this is just y2 plus, this is y1 minus 3 cosine log x. I'll take minus common, so inside the bracket you will get the plus 4 sine of log x. Now look at the bracket carefully. What is this bracket? Bracket is just nothing but y. So therefore x square y2 plus y1 equals to minus y. And therefore finally we are getting x square y2 plus y1 plus y equals to 0 proved. This is what the proof. Third question, next question, 14th question here. Question number 14. You are given y equals to a into e raised to mx plus b into e raised to nx, I suppose. Okay, so we differentiate it. So dy by dx equals to a being constant as it is. Imagine this is x. What's the derivative of e raised to x? E raised to x. By chain rule derivative of mx, that is m, plus b as it is. Imagine this is x. What's the derivative of e raised to x? E raised to x into by chain rule derivative of nx, which is n. So we are getting here a into m into e raised to mx plus b into n into e raised to nx. This is dy by dx. Now again we differentiate it. So again differentiation here. That is d square y by dx square. A m being constant as it is. What is derivative of e raised to mx? That is e raised to mx into by chain rule derivative of mx, which is m, plus b n as it is. What's the derivative of e raised to nx? Imagine this as x. So e raised to nx into by chain rule derivative of nx, which is n. All these things you know now. So therefore d square y by dx square equals to a m square into e raised to mx plus b n square into e raised to nx. Now this is not the required proof. This is, you don't want this on the RHS here. So what we do, This is also standard way. You can call this as 1 given equation. Call this as 2. Equation obtained after differentiating once. Call this as 3. Right. And we put these values in the LHS here. So from 1, 2 and 3, from 1, 2 and 3, we have LHS here. That is d square y by dx square minus m plus n into dy by dx plus mn y here. This I'll not do. What you have to do, put the from 1, 2 and 3, put the value of dy by dx minus, keep m plus n as it is, into, put the value of dy by dx from 2 here. From 2 you put the value of dy by dx plus mn as it is. Inside the bracket you put the value of here y. And you simplify, you will see that all will get cancel internally, which is 0, and this is RHS. This is also standard way of doing this. In previous question, if you look at there, just by differentiating twice, you could get this directly, remember. Here, once I differentiate twice, I am not getting what I want. So what I'll do, I'll put y dy by dx and d square by dx squared on the left hand side, and I got the 0 here. This is also a standard way of proving double derivatives, remember. The next question, 15 number, you have y equals to this, you want dy by dx first. So 500 being constant as it is, imagine this is x, derivative of e raised to x is a raised to x. By chain rule, derivative of 7x is 7 plus 600 as it is. What is derivative of e raised to minus 7x as it is, into, by differentiation of minus 7x by chain rule minus 7. Okay. Again we differentiate this. Again differentiating. So we'll get the d square y by dx square equals to 7 as it is, 500 as it is, being constant. Differentiation of this portion. Again imagine e raised to 7 is x. So derivative of e raised to x is e raised to x. As you did there, differentiation of 7x is 7. Here plus 600 as it is, minus 7 as it is. What is this? E raised to minus 7x by chain rule derivative of this, which is minus 7. So now clearly you can see that 7, 7, 7, 7, 49 you will find common. This is 500 into e raised to 7x. This minus minus is plus 600 into e raised to minus 7x. And just, what is this? You know that this is just y. So you can call this as 1 here, and here you can write by 1. And therefore, finally, we are getting this d square y by dx square equals to this, and therefore proved. Okay. Now next question, question number 16 here. You are given e raised to y into x plus 1 equals to 1. This is given, and you want to prove this. Prove that d square y by dx square equals to dy by dx the whole square. This is what you want. Okay. So what I'll do is, this is like implicit function, you must have realized. So I'll differentiate it with respect to x directly. Just differentiating with respect to x. Okay. So on the left hand side, product rule, e raised to y into dy by dx as into x plus 1 as it is, plus e raised to y as it is, differentiation of this is 1 plus 0, on the right hand side you have 0. I repeat this. What I did, I've used the product rule. First, keep this one as it is. What is differentiation of e raised to y? Imagine y is x. So derivative of e raised to x is e raised to x into by chain rule derivative of y with respect to x dy by dx. This is as it is. Plus, now e raised to y as it is. Derivative of bracket. Derivative of x is 1. Derivative of 1 is 0. On the right hand side, derivative of 1 is 0. So you will find e raised to y common. What will get inside the bracket? X plus 1 into dy by dx plus 1 equals to 0. Now if you remember, exponential function is never 0. So you can take on the other side. So x plus 1 into dy by dx equals to, plus 1 equals to 0. You already studied exponential function. This never be 0. So I can take this one on the other side, remember. That you know. Okay. So finally, therefore, here dy by dx equals to, we are getting, take 1 on the other side, minus 1 upon x plus 1. We are getting this. This is dy by dx. Call this as 1. Fine. Now we get the double derivative. I'll differentiate this square y by dx square. So here, therefore, d square y by dx square equals to, chain rule, you know how to do this. Imagine this as x. What is derivative of 1 upon x? Minus 1 upon x squared. Minus sign already there, so they become plus. Into differentiation of this bracket, that is 1 plus 0. So you are getting 1 upon x plus 1 the whole square. D square y by dx square. This is 2. And now just look at it 1 and 2 both. You will get exactly LHS equals to RHS. It's proved. D square y by dx squared, that is LHS. RHS, if you look at here, RHS is here only, which is dy by dx the whole square. This is RHS. Right? So if you square this, you will see that the both are equal. Okay. Now, last question here. Question number 17, which is an important example. You are given y equals to tan inverse x the whole square. We want double derivative, so we just differentiate it once, differentiating with respect to x. So y1 equals to derivative of y with respect to x, y1. Imagine this bracket as x. So this looks like x squared. What is derivative of x squared? You know, 2x. Into, by chain rule, derivative of tan inverse x, which is 1 upon 1 plus x squared. Remember, you have used the chain rule here. Now before I get into second derivative, I'll take this expression over here. Normally, in double derivative questions, before you do it second time, you should simplify derivative obtain once. Right? Don't go for y2 directly from this blindly. That sometimes becomes difficult, not every time. So what I did, I took this expression on the left hand side. Now usually, this is also very standard technique. Before I differentiate, I should convert this one in form of y. So I need square, so I'll square this, squaring the given expression, that is 4 tan inverse x the whole square, which is y. What I did two things. I have squared, and RHS will be tan inverse x the whole square, which is y. First 1 plus x square on this side, then I've squared it. Yet I have not started with the second derivative, remember. Normally, before you differentiate it twice, you should try to convert in form of given expression, that is y. Later on also you will come across through number of such questions, you will realize. Okay, and now differentiation, remember, again differentiating. So what is left hand side? It's a product of two functions, remember. One is this, the other one is this. So I'll keep y1 square as it is. Differentiation of this portion here. So there I need to use which rule? Chain rule. So twice 1 plus x squared. Imagine bracket as x squared 2x into, by chain rule, derivative of the bracket. Derivative of 1 0, derivative of x square is 2x. Plus, now 1 plus x squared the whole square as it is. Differentiation of which portion now? This one. Differentiation of y1 squared. Now again you need to imagine y1 as x. So what is this? This looks like x square. What's the derivative of x square? 2x. So 2y1 into, by chain rule, derivative of y1. Derivative of y1 with respect to x is d square y by dx square, which is y2. I explained this here separately. You see what I'm trying to tell you is differentiation of y1 square. So we imagine this as x. So this looks like x square. So 2x, that is 2y1, into differentiation of y1, that is derivative of y1 with respect to x, which is y2, that is d square y by dx square. So keep this one in your mind, remember. Differentiation of y1 square is 2y1 y2. Okay, come to this. Now RHS, what is right hand side? 4 being constant as it is. Differentiation of y with respect to x, that is dy by dx, which is y1. Now here you will see that you can find 2y1 common. So dividing by 2y1, this is common throughout, you can see on both the sides. So here 2y1 will get cancelled, so we'll get the 1 plus x squared 2x, 2 will goes away, 1 y1 will goes away, so we'll get just y1 here, plus this one will goes away, so 1 plus x squared the whole square into y2 equals to just 2. This is just 2, and this is what you want proved. This one you want.